Good morning, ladies and gentlemen. I had a planned absence today. This lesson on scientific notation is what we were going to have on Wednesday before we had learned we had a snow day. Scientific notation is not particularly difficult. We will get into some more difficult aspects on Monday when I am back. So scientific notation is a shorthand way of writing really large numbers. Actually, you know what? I'm going to change this. I don't want to use black. I want to use blue. Really large numbers or really small numbers. So that way you can take a number like 58,527,328,062 and write it without having to make so much effort. It allows us to compute them more easily, compute with them more easily. So scientific notation, when we write it, is written as the product. Remember, product means multiplication of two numbers. The first one has to be a number that's between 1 and 10. And the second one has to be a power of 10. So when you have seen scientific notation in the past, it has looked like this. 3.7 times 10 to the negative 8th. That's an example of scientific notation because this first number is a number that's between 1 and 10, and the second number that we're multiplying is a power of 10. And what's important that you understand is that power of 10 has to be an integer. So no decimal parts, no fractions. It has to be negative 8 or 0 or 5 or 13, but it cannot have a decimal. Okay, so that's what scientific notation looks like. Now, if we want to convert something from standard notation, which is the way that we're used to seeing numbers, into scientific notation, the first thing we need to do is move the decimal point to create a number that's between 1 and 10. So create a number that's between 1 and 10 by moving the decimal point. For instance, if you had the number 37,120, the decimal point is currently right here at the end. We want to move it right there so that we have 3.712, which is a number that's between 1 and 10. So when you do that, actually, I should stick with that, 37120. If you take your decimal point and move it from here to right there, you've now created a number between 1 and 10. 3.712 is between 1 and 10. You count the number of times that you move the decimal point. This number will be your power of 10. Okay, this number will be your power of 10. And what that means is, for instance, right here, we moved it 1, 2, 3, 4 places. And it would be 4 would be the power of 10. But you need to be careful, because if your number is greater than 1, meaning if that number is large, the exponent will be positive. So for this number right here, since we moved the decimal point 4 spaces, 4 would be our power of 10. If your number is less than 1, meaning small, the exponent will be negative. So let's look at a couple of examples. So we need to take this 1,850,000 and we need to change that into scientific notation. So we want some number that's between 1 and 10 multiplied by a power of 10. So what's that going to look like? Well, first off, we currently have a decimal point right here. We are going to move it right there. Now, the number 1,850,000 is a big number, which means that we are going to have a positive value that goes right there. What is going to be our first number? The number that we're going to multiply by? Well, we moved our decimal point between the 1 and the 8, so that gives us 1.85. If you want to write all those zeros out, you can, but I do not recommend it. And then we want to count this and see how many places did we move the decimal point. 1, 2, 3, 4, 5, 6. We moved it 6 places. So that is our number written in scientific notation. Moving over here, we want to convert this one into scientific notation. So again, our decimal point is currently right there. We are moving it right there. So how many places did we move the decimal point? 1, 2, 3, 4. So that means what we have is 4.2 times 10 to the 4th. Now we got a difference here. Now we have smaller numbers. What that tells us is that our exponent on our power of 10 is going to be negative. So when we want to take our decimal point, we're going to move it from here to there so that we create a number that is between 1 and 10. So that number that's between 1 and 10 is 7.826 times 10 to the, and how many places did we move it? 1, 2, 3. And it would be then -3 because that's a small number. On this next one, you want to convert this number to scientific notation. The decimal point is currently here. We want to move it right there. So how many places, well, let's maybe slow down a little bit there. Our number that's between 1 and 10 is 1 times 10 to the, how many places did we move the decimal point? 1, 2, 3, 4, 5. The number was a small number, so what goes here is -5. Okay. So that is how we change something from standard notation to scientific notation. So that's page 1 from your packet. Now let's move to page 2. Here we are converting from scientific notation to standard notation. So now you have to move the decimal point the same number of places as the exponent that you have. If the exponent is positive, you want to move the decimal point right in order to make the number larger. And in my opinion, it's less important that you remember this part and more important that you remember that part. You need to remember that a positive exponent means the number gets bigger. Right here, if the exponent is negative, move the decimal to the left. I never, as a student, could remember whether to move left or right. It was better if I just thought that a negative exponent meant my number was going to become smaller. So again, if you have a negative exponent, the number gets smaller. A couple of examples for you. Actually, just, what do we have? Not too many more examples, and then you're going to do your homework. You want to convert the number to standard notation. We see we have a positive exponent. That means that this 7.83 is going to get larger. Now this one, unlike the last examples I did, I like to actually rewrite this. So I want to move this 7 places to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and there's going to be a decimal point right there. So I'm going to have the zeros filled in right there. So what is my final answer going to be? It is going to be 7. Ooh, I'm going to change that. 7, 8, 3, and then 1, 2, 3, 4, 5 more decimals. 3, 4, 5, and I'm going to throw commas in there every 3 places. It's just a little bit easier to read Okay, so let's look at the next one. Again, I really do prefer rewriting it 2.5 all by itself here. And then we've got 4, which is positive. So I want to make this number bigger. So I'm going to go 1, 2, 3, 4. Fill in zeros here. And that leaves me with 2, 5. This right here, that's my old decimal point. Now I've got a new one, which is right there. So don't keep this one right here. We're not putting that there. That's gone now. So 2, 5, and then 1, 2, 3 zeros. So that became 25,000. I'm sorry about the background noise. It's probably obnoxious, but I'm in a hotel and I had to get out of my room because I have a roommate. Okay, convert the number to standard notation. Next, same thing, except this time we have a negative exponent. So that means we want to make this number get smaller. So I am going to take this 8.3, ooh, you know what? Now that I see this, I need to write it over here. 8.345, because that's a negative 6 right there. I need to make it smaller by moving to the left. So I'm going to go 1, 2, 3, 4, 5, 6 places, and there's my new decimal point. So I'm going to fill in the gaps here with zeros, 4 and 5. So what is my final answer? It is 0.00000. 1, 2, 3, 4, 5, then 8, 3, 4, 5. And some of you would like to put that 0 in the front there, and that's perfectly fine to do that. So again, just to make sure you're with me here, there's a decimal point that was there. I moved it 1, 2, 3, 4, 5, 6 places, and that's where my new decimal point went. Here's another example with a negative exponent. So again, negative exponent means that 3 is going to get smaller, so it's going to look something like a 0.3 or a 0.03 or a 0.003, who knows? What we do know is that right now, the decimal point is on that 3, it's here, and we need to move it 3 places left because it gets smaller. 1, 2, 3. So that's 0.003. So final answer, 0.003. You can put a 0 there if you want. So again, just a reminder, we started out with a decimal point there. We moved it 1, 2, 3 places to the left. Let me see if... So we have to complete the missing blanks in this table below. What I want you to do is finish this as part of your homework. So this is should be the bottom of page 2. So you're just changing this number into scientific notation and this number back into standard notation. And then you're also completing page 3, which is right here. Now what you have to do on page 3, it says Calvin practiced converting standard notation to scientific notation by completing the 10 problems in the table below. Unfortunately, he made mistakes on 7 of these problems. So what we need to do is find out where the mistakes are. So let's take a look at problem number 1. Did he make a mistake? Well, when I look at this, what I see is that this number is between 1 and 10. That's positive. That's a good thing. It should be. But I notice that that is an 8. When I look at this problem over here, at the standard notation, the decimal point is there, and it was moved 1, 2, 3, 4, 5, 6, 7 places. So that right there should have been a 7. So a mistake that was made was in problem 1. Problem 1, His mistake is that his exponent should have been 7, not 8. So the correct answer is 7.645 times 10 to the 7th. And that is your lesson for today. Again, just to make sure you followed me, we took notes on this page and did 4 examples. We took notes on this page and did 4 examples. You need to finish the bottom as part of your homework, and then you need to find the 7 mistakes. We already found one. You need to find which 6 problems from these have mistakes. So 3 of them don't have mistakes. I hope you have a great day, and I look forward to seeing you on